So welcome to the mathematics revision of the Gce 2025 paper 2, as I now try to focus my attention on question number 2. So this is question number 2 we are looking at, that is 2a. So it says express 5 over x minus 1 minus 2 over x minus 2 as a single fraction in its simplest form. So they want you to express it as a single fraction in its simplest form. So if you have been given 5 over x minus 1 minus 2 over x minus 2, you need just to find the common denominator. And of course, if these are different, so you can pick up that as, you can just get that term x minus 1, put it in bracket, and bring this one as close as possible, x minus 2, and also put it in bracket. So that becomes your common denominator. Now when you get this as your common denominator, that is the same as saying you get this term, multiply it by that, and you get that term, and you multiply it by that, by the 5 there. So it's like when this goes there, this and that will cancel, you remain with this will multiply by 5. No wonder we're just saying this times that. So it will be 5 times x minus 2. Then remember there's a minus sign there, very important there. In the exam they'll have a negative sign there. When x minus 2 goes into the comma, it's like this and that will cancel, you remain with x minus 1 times the number on top. That's why we say this times that. So don't waste your time. This will be x minus 1. Then we can expand what is on top and collect the like term. So 5 times x will give me a 5x. 5 times negative 2 will give me negative 10. Please, when it comes here, most people make mistakes. They say 2 times x, which will give you, yes, 2x, and 2 times negative 1, they still have negative 2. This is wrong. So the moment you come here, the sign, this number together is with the sign, negative sign. So it's negative 2 times x will give you negative 2x. Negative 2 times negative 1 will change to a positive 2. So the moment you made a mistake there, it simply means that your mathematical problem is wrong. So over, you just keep on retaining your denominator. So that is x minus 1, and that will be x minus 2. All right. So mathematical problems, and these are not equal sign. I'm just indicating that the mathematical problem, continues. So we continue with the like terms, this and that. So that is going to be 5x minus 2x. That is minus 10 plus 2. Remember, the signs do not change because you are not crossing the equal sign. So that will be x minus 1 in brackets and x minus 2. What is 5x minus 2x? That is going to give me a 3x. Negative 10 plus 2, different signs, you subtract and get the sign from the bigger number. Therefore it will be negative 8 over x minus 1, and that will be x minus 2. Can we simplify that further? The answer is no. So therefore this is our final expression that we are going to have. This is our final answer that they wanted you to get there. All right, so this is how you needed to do it so that you can get your 3 marks. Let's move on to question number 2b. Please pay attention for question number 2b there. So for question number 2b there, this is coming under the topic we call as being calculus. I believe you still remember concept under calculus. It says find the equation of the tangent. Now if you want to find an equation of whatever that you need, an equation, one, you need to know the equation of a straight line. Y is equal to mx plus c, where m is the gradient and c is the y-intercept. But don't worry, there are so many equations that you can use for the equation of a straight line. But you also need to know how to find the gradient, the change in the y-step, y2 minus y1 over x2 minus x1. This is only applicable when they have given you 2 points. But in our case, because we are looking at calculus, this gradient will be given by dy over dx. So that is the way we treat it that way. Now notice again, it says find the equation of a tangent to the curve, that one, at the point where x is equal to 1. So since it is at the point where x is equal to 1, what is the value of y at that point when x is equal to 1. That's the first thing that you need to start finding. Find the value, the corresponding value of y if you have not been given. How? By replacing into the equation of the curve. So y is equal to x raised to the power 3 minus 5x squared plus 8x minus 4. We replace where there's x, I'll replace with 1, so it will be y is equal to 1 raised to the power 3 minus 5, 1 raised to the power 2 plus 8 times 1 minus 4. So y is equal to 1 raised to the power 3 is 1, 1 raised to the power 2 is 1 times 5 will give me a minus 5, 8 times 1 will give me a positive 8, and that will be a minus 4. So if you use your calculator, if you want, you can work out that, and I believe that is going to give us a 0. So it is 1 minus 5 plus 8 minus 4 there, that is going to give you a 0. So meaning at that point when x is a 1, y is equal to 0. Remember, it's a coordinate x and y. When x is 1, y is equal to 0. You need this coordinate later on to find the equation of what we are calling as being the tangent. All right. So the next thing that we are going to do is first, find, dy over dx at the point where x is equal to 1. So that is what we are going to do. We are going to find dy over dx at the point where x is equal to 1. So how are we going to do it? Remember, we can differentiate that one, dy over dx. In case you are still lagging, you can go back on some other videos that I made on calculus, then you can learn how to go about that. So remember, that one is going to give us, a 3. This times the number in front, and that reduces by 1, so it will be 3x raised to the power 2. Then this times that will give us negative 10, and the power reduces, that will just give me x. When you have a number and a letter, you just remain with a number. Remember, just the number will give you a 0, so you can actually ignore it. So that you can actually ignore it. If you want, we can put it as 0 there. So now in this case, it will be 3x squared minus 10x plus 8. But dy over dx at the point when x is equal to 1. So what is the gradient? Dy over dx is representing the gradient. Remember what I said? So now what is the gradient now? So you need to replace this one into this expression so that you can know the actual gradient. So it will be 3 multiplied by 1 raised to the power 2 minus 10 multiplied by 1 plus 8. So that will be 1 raised to the power 2 is simply a 1 times 3. That will be a 3. 10 times 1 will give me minus 10, then that is going to be plus 8. Then you can work out that using your calculator, and that will give us obviously a 1. So let's look at that. 3 minus 10 plus 8, that is going to give us a 1. So meaning that the gradient, in other words, dy over dx is a 1. Therefore you can say the gradient of the tangent, this is what you get is exactly the gradient of the tangent is a 1. So now you are going to get now in step number 2, you are going to in step number 2 now, you simply need to get the gradient of the tangent, which is 1. And this point that you found, 1, 0, and that will help you to find the equation of the straight line. So remember, y is equal to mx plus c. So we need now, to find c, the y-intercept. By replacing, remember, this is your x, this is your y, and your gradient, so that we can find c. So what is my y? It is 0 is equal to the gradient, it's 1 times my x, which is a 1, plus my c, which we want to find. So that would be 0 is equal to 1 times 1 is 1 plus c. So when this one crosses that side, it will be negative 1 is equal to c. Therefore, c is equal to negative 1. So once you get your c as your negative 1, therefore we can simply say equation of tangent. So the equation of the tangent will be given by y is equal to, we replace the c and the gradient into that equation. That is the equation of the tangent. So what's the gradient? It's 1, but 1 times x, and what is our c? Remember, it is negative 1. So it will be y is equal to 1 times x will just give you x, positive and negative will give you a minus 1. So this is actually your equation of the tangent. Remember, they can also tell you to find the equation of the normal. It is possible, but this is how you needed to do it. Thank you so much for watching. Watch out for question number 3 as I continue in revising this GC 2025 paper 2 mathematics series.